Good morning, students. Today we will discuss about the concept of left recursion. Okay, in previous class we have discussed that the context-based grammar and top-down parsing, all those things we have discussed. Okay, so we have discussed left derivative also. So next concept is that is nothing but a left recursion. Okay, the outline of this today's class is we will discuss about what do we mean by left recursion and what are the different types of left recursion, that is immediate left recursion and indirect left recursion, and how we will remove the left recursion using some examples. Okay, so that is examples on left recursion and algorithm for left recursion. So these are the concepts we need to study in this today's class. Okay. Okay, in previous class we have discussed about recursive descent parser, that is top-down parser. So that is we are constructing from root to leaves. Okay, so using left derivatives, that one we will call it as a recursive descent parser. We have discussed that one in previous class. Okay, so this recursive here, when we will not construct a recursive descent parser for a particular grammar. Okay, so we will have a number of productions. Using that productions, we will derive a parse tree using left derivative. Okay, so when we will not construct a parse tree for a particular grammar. Okay, so when the grammar having ambiguity. Okay, so the first thing is ambiguity. When the grammar is having ambiguity, we can't construct a recursive descent parser. So the solution is to eliminate that ambiguity from the grammar. We have discussed lot of examples how to remove an ambiguity from the grammar. Okay, so that is one thing, removing ambiguity from a grammar. Okay, so when a grammar having ambiguity, it's not possible to construct a parse tree. One thing. Then after that, second one is left recursion. That is today's concept. Okay, so here left recursion, we will discuss what do you mean by left recursion. Okay, the solution is to eliminate left recursion from the grammar. Okay, so next third one is left factorizing. That is two or more alternatives having a common prefix. The solution is to left factor the grammar. Okay, so these are the three things. The first one we already discussed. Okay, ambiguity, how to remove ambiguity. Okay, from the grammar we have discussed in previous classes. Then left recursion we will discuss today class. Next one, left factorizing, will be discussed in tomorrow class. Okay, so now we are concentrating on left recursion on this today's class. What do you mean by left recursion? Okay, so here suppose if we have a production A tends to A capital A alpha. Okay, so here a grammar G is said to be a left recursive if it has a non-terminal A such that there is a derivation of the form A tends to capital A alpha. So that is this is variable from left side. Okay, so after in the right side, if the same symbol is exist. Okay, if the same symbol, suppose if A is there, here also A, capital A is there, that is here also non-terminal A. After left side also, first one is non-terminal. Okay, so then we will call it, then after that we will have a alpha terminal or a symbol. Okay, so if we have a grammar, a production, A tends to capital A tends to capital A alpha. Okay, so then that form we will call it as a left recursion. So that is A tends to A alpha. So if left side, the first letter will be variable of the same right side, so then that one we will call it as a left recursion, where alpha is a string of terminal and non-terminals. That is, whenever the first symbol in the partial derivation is same as the symbol for which partial derivation is obtained, okay, then that grammar is said to be left recursive. Okay, so here if it means if left side is, yeah, variable is there, same variable at left side, same thing is there, then that one we will call it as a left recursion. When you substitute for this, A tends to A alpha, so when you substitute for this A, so I will get one more A alpha. So when you substitute for that A, one more A alpha, one more A alpha, like that there is no end at all. Okay, so we can generate n number of A's and alphas. Okay, but when we will come out of that, so we can't come out of that one we will call it as a left recursion. Okay, so here A tends to A alpha, in this form of the grammar we will call it as a left recursion because there is no end for the substitution. Okay, so for this A you can substitute n number of time A alpha. Okay, so but we won't get final A answer. Okay, so that one we will call it as a recursion. Okay, that form we will call it as A tends to A alpha, so this one we will call it as a left recursion. So in that we have two types, immediate left recursion and indirect left recursion. What do you mean by immediate left recursion? Okay, the grammar G is said to be have an immediate left recursion if it has the form A tends to A alpha. A tends to A alpha. That is, so here left side is also variable A is there. In right side also, a first one is variable A. So then that one you will correct as a immediate. Okay, so immediate, it means, so same thing will be present on left side also. So then we will correct as a immediate left recursion. For example, so E tends to E plus T. Okay, so slash T. So here E tends to E. So here we have a immediate left, we have same variable. Okay, immediate left we will have same terminal E tends to E alpha E plus T. So here we have a same terminal is there. So that's why this is also left recursion. Then T tends to T star F. Okay, so the left side will have a T, same variable T is there. That is also a immediate left recursion. Then F tends to EID. This is not left recursion. So here we don't have same F here in the left side. This is not this is not contain a left recursion at all. Okay. So in the above grammar, consider the two productions E tends to E plus T and ET tends to T star F. These two are the two productions. So here observe in that above two production, the first symbol on the right hand side of the production is same as the symbol on the left hand side production. Okay, if the symbol is same as the right hand side production, is same as at the left hand side productions, then that the given grammar as immediate left recursion. So in the given grammar, these two are the immediate left recursion. Nothing. See here, suppose if you substitute for E, then you will get E plus T. Once again, if you substitute for E, you will get E plus T. E plus T. Like that, if there is infinity, there is no end at all. Okay, so from the left side, so that's why we will call it as an immediate left recursion. Okay, so this is immediate left recursion. Next one is indirect left recursion. Okay, so this is also we will go for infinite only. Okay, so the thing is that is the transitive dependency A tends to B tends to C. So that is, so that one we will call it as a indirect. Okay, so I will come to that. Okay, so a left recursion involving a derivation of two or more steps, so that the first symbol on the right hand side of the partial derivative is same as the symbol from which the derivation started is called indirect left recursion. See here, the first symbol on the right hand side of the partial derivative is same as the symbol from which derivation is started. Okay, see here in this grammar E tends to T. Okay, so here E tends to T, then T tends to F. Okay, so E tends to T. Okay, so then after that I will substitute for T, then that is a T tends to F. So then F tends to E. Okay, so E tends to T, T tends to F tends to E. Okay, so it means, so here I will E tends to T. For T I will substitute F. For F if I substitute I will get E plus T. So it means, so this last production, okay, so this last productions is dependent on once again E only. So it means E plus T or ID is dependent on E only. So we can write this one as E tends to E plus T slash ID. So that is, it is indirectly left recursion, left recursion. That is, it is indirectly dependent on this E plus T. Okay, E plus T or ID is independent, transitively or indirectly it will be dependent on E only. We consider the following derivation: E tends to T, T tends to F tends to E plus T. Okay, so here then once again this left side is equal to, that is in this production, in right side also the first symbol E only. So that is the same production will be derived indirectly. So that's why we will call it as, this one is also a left recursion. Okay, so here finally when you substitute this E to T, T to F to E plus T only, that is E for beginning also E, then we will write this production E tends to E plus T only. Okay, so that one we will call it as an indirect left recursion. Okay, so here when you want to, so same thing, so in the above derivation note that the partial derivation get the string e plus t. The first symbol is e, which is same as the symbol from which derivation started. But the string e plus t is obtained from e by applying two or more productions. So finally, we will obtain e plus t by applying the two or more productions. So the given grammar, even though it is not having immediate left recursion, but it has an indirect left recursion, and hence the grammar is left recursive. So indirectly, that e plus t is indirectly dependent on e only. So then we will write e tends to e plus t. Okay, so it is indirectly dependent. That's why we will call it as a, this is left recursion, indirect left recursion. Okay, because it is indirectly dependent on e only. Okay, same variable dependent on that is same, that is e plus t is dependent on e only, that is indirectly. That's why we will call it as indirect left recursion. So now we will how to overcome this left recursion. Okay, so how to overcome this left recursion? See here, consider we will make a one general format. Okay, so general format we need to do for left recursion. Consider the a production a tends to a alpha or beta. Okay, so here this is a, it is in a left recursion a. So then after that we will have a non-terminal terminal symbol alpha and another terminal. Okay, so here, so a tends to a alpha. This is it is in a left recursion, and b is not start with a. Okay, a tends to b only. Okay, so note that the above grammar has the left recursion. That is a tends to a alpha is having left recursion. Now let us see how to eliminate this left recursion. Okay, so how we will overcome from that left recursion? It means any grammar, it should not be in the form a tends to a alpha. We need to overcome from that. Okay, so here for that, suppose if you substitute the things, we will get. Okay, so here first one is a tends to alpha. Can we write this is the first derivation? A tends to a tends to beta. Okay, so we can write a tends to beta. Okay, a tends to a alpha or a tends to beta. Okay, we have written a tends to beta. So then a second derivative, a tends to a alpha. Okay, so a tends to a alpha. A tends to a alpha we have written. For this a we can substitute beta because we have a derivation a tends to beta. Okay, so now we will have beta tends to beta alpha. Okay, a tends to beta alpha we have got. So then third one, a tends to a alpha. Okay, so when I substitute this one for a, I will get when I substitute a alpha once again, so I will get a alpha. So this is for substitution of this a alpha, and this alpha this. Okay, so for this a I will substitute beta. Okay, so because we have a derivation beta, so then this is beta alpha alpha I got. Then in the fourth derivation a tends to alpha. Okay, I will substitute for a alpha. Once again I will substitute a alpha. So like that I will two times I substitute for a, that is a alpha I will get a triple alpha. So after that I will substitute a for beta. Okay, so substitute beta is substituted. Now I got beta triple alpha. Okay, so like that we can generate the n number of derivation, beta alpha 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 3 alpha beta 4 alpha beta 5 alpha, like that we will generate. See here, this is first derivation only beta, second derivation beta alpha, third derivation beta alpha alpha, fourth derivation beta alpha alpha alpha, then fifth derivation beta 4 alphas. So like that we can generate n number of beta alphas. Okay, so now we can write that grammar. Okay, so that is L is equal to a beta. Okay, alpha it may be n number of times, I greater than 0 or more. Okay, so it may be 0 or it may be more. That is, so here see here beta. So first time no alpha, first 1 alpha, 2 alpha, 3 alpha, 4 alpha, 5 alpha, 6 alpha, 7 alpha, 8 alpha, 9 alpha, 10 alpha. You can write any number of alpha, but beta is 1. So now we can write that param is L is equal to 1 beta then alpha I. Okay, alpha whole power I. So it means I may be, it may be 0 or it may be 100. We can write if we have a left recursion. So for that what we are doing, so we will write that is as a tends to beta into alpha whole square whole power of I. So it will be, we will make it as a dash. Okay, so we may get n number of alphas. So for that, what we are substituting, it will beta is only one, it will be a dash. A tends to beta a dash, where a dash should generate a zero or more alphas. Okay, so a generate we can zero or more alphas. Okay, so then okay, a tends to beta a dash. Now what about that a dash? So we need to come to n now. So here from a dash we can get zero or more alphas. Okay, so here we may get zero or more alphas using the production. So here epsilon is nothing but a constant, it will be zero. Okay, so a dash, then alpha dash alpha a dash. Okay, so we may substitute alpha a dash. It means so a dash will be, it may be alpha or epsilon. Okay, it may be zero or it may be alpha a dash. Alpha a dash means, so if you substitute a dash, we may get n number of alphas. Okay, so a dash alpha a dash alpha a dash alpha. We can get n number of alphas. Okay, so the final grammar generated beta followed by zero more alpha, which don't have the left recursion. So here we have a tends to beta a dash, then a dash is nothing but epsilon or alpha a dash. Check it if you have any left recursion in this. A tends to beta, so there is no a here. A dash also we don't have. Here alpha is there, after that a dash is there. So it means, so we have overcome from the left recursion. So when they give the production, okay, so when they give the production, when they give the left recursion, so we will have, we need to write, suppose if they give the recursion, left recursion a tends to a alpha, then you need to write in the form of a tends to beta a dash, and a dash is equal to epsilon alpha a dash. We should write this one. So you should, if you know this thing, so easily you can write any left recursion. We need to overcome from the left recursion. Suppose if we have a grammar a tends to a alpha, so then we will write that one into a tends to beta a dash is equal to epsilon in or alpha a dash. Okay, so here thus the grammar which has left recursion can be written in the form of another grammar that does not have the left recursion. Okay, so a tends to the in the left recursive a tends to a alpha beta, then a dash is equal to epsilon alpha a dash. Okay, in general, if we return a tends to a alpha 1, a alpha 2, a alpha 3, a alpha n, then beta 1, beta 2, beta 3, beta n. So this is in general we will write this one. Suppose if we have more productions, here we have only one production, a tends to beta, a tends to a alpha. So if we have more than one productions, we will write in the general form a tends to a alpha 1, a alpha 2, a alpha 3, and a alpha n, and beta 1, beta 2, beta 3. That's it. Okay, so if you have a right recursive grammar, so we will concentrate only on left recursive. So in general, a tends to beta a dash. Okay, so a tends to be beta 1 a dash, beta 2 a dash, beta 3 a dash. Okay, so then a dash will be alpha 1 a dash, alpha 2 a dash. So like that we will write in the general. We will take an example. Okay, so please concentrate on this. A tends to a alpha beta, then okay, so a tends to a alpha beta. So if we have that grammar, we will write that one a dash epsilon alpha a dash. So that is beta into a dash, a tends to beta into a dash into epsilon alpha a dash. Okay, so please concentrate on this. Okay, so we'll take one grammar. Okay, so eliminate the left recursion from the following grammar. Okay, so in the line exams they will give like this: eliminate the left recursion from the following grammar. So here in this they have given the grammar e tends to e plus t. So here e tends to e plus t. So here we will have a left recursion. E tends to e plus t. Here we have a left recursion. Okay, done. So then here t tends to t star f. So here also we will have a left recursion. So t tends to f. Okay, we don't have. Then f tends to e or id. So here we don't have left recursion. So now we need to concentrate these two. Okay, these two having the left recursion. So e tends to e plus t or t, and t tends to t star f or f. So in these two things we will have a left recursion. Okay, so solution, since the first symbol on the right hand side of E production and T production is same as the symbol on the left hand side of the production, the grammar is having immediate left recursion. Okay, so because E tends to E plus T, so that is here we will have a left recursion. So this E same variables are there from left side and right side first letter. So it means these two are in left recursion. Okay, how we will overcome? Same formula. Okay. So here, this is the general formula. A tends to A alpha 1, A alpha 2, A alpha 3. So first you need to identify these things. So here, because here we have two productions are there for the one variable, E tends to E plus T and RT. So here we need to identify alpha and beta. Okay. See here, A alpha 1. So this is E is A. Okay. So A tends to A alpha 1. Okay. So E, you make it as a and this E make it as a. So then after E, whatever the things are there, so we will make it as alpha 1. Okay. So plus T, we will make it as an alpha 1. So then next T, it will be beta 1. Okay. So we have A alpha 1, beta 1. So this form, you should write all the productions. Okay. See here. A alpha 1, A alpha 2, A alpha 3, like that we can write anything. Then after that, beta 1, beta 2, beta 3. So then A alpha 1, beta 1, we need to write here. So here we have A is there. Okay, so substitute with that is A. You should write in the form of A alpha 1, beta 1. So here E is A. So then E we will make it as A. This plus T we will make it as an alpha 1. Okay, then this T will be make it as beta 1. Okay. So then what we need write here, so we will write this in the right recursive form. How we will write? A tends to beta 1 into A dash. Okay. So here we will have beta 1 into A dash. So here, which is beta 1? Beta 1 is E tends to, so here beta 1 what? That is T. Okay, beta 1 T. Then E dash. Okay, A dash is nothing but here E dash. Okay. So then E dash that is A dash tends to alpha 1 A dash. Okay, E dash tends to alpha 1 is what? Plus T. Alpha 1 is plus D. So then A dash. A dash is nothing but E dash. Okay. So then after that we will have an epsilon. Okay. So here same thing. You should make this form and you should represent like this. Okay. So here make a left recursion, that is A tends to A alpha 1, A alpha 2. That is A tends to A alpha 1, beta 1. In this form we are doing for the given grammar, for the given left recursion grammar. Okay. So what we are doing? So here they have given E tends to E plus T or T. Okay. These productions they have given. You should match with this A alpha 1, beta. Okay. So here E is nothing but A and this E becomes A. So then this plus T becomes this alpha 1 and this T becomes beta 1. Okay. So you should remember that one. So you should make this one. Then after that you should write in this form. A tends to beta 1 alpha. Okay. So here beta 1 A is nothing but E. Okay. So E tends to, which is beta 1? Beta 1 is nothing but a T. I have written T. So then A dash. A dash is nothing but a E dash. Okay. So then here A dash is equal to alpha 1 A dash epsilon. Okay. So A dash is nothing but E dash. Alpha 1 is nothing but plus T and A dash is nothing but E dash and epsilon. Like that. Okay. So like that we have written the productions. Check it. So E tends to T E dash. E dash is equal to plus T E dash. So here we don't have left recursion. It means we have changed this one. E tends to E plus T or D will be in the form of E tends to T E star plus T E dash epsilon. Okay. So like that we have written. Same thing we have. So write in this form A alpha 1 beta 1. Same thing. So here T tends to T star F or F is there. So here T is nothing but A. This T is nothing but A. Star F I am making it as an alpha 1 and F is nothing but a beta 1. Write in this form. A tends to beta 1 A dash. So here T tends to A is nothing but T. T tends to beta 1. Beta 1 is nothing but star F. Okay. So beta 1 is nothing but a Okay, so here beta 1 is nothing but a f. I have written t tends to f. Okay, so then a is a dash. A dash is nothing but a t dash. Okay, so then this t dash tends to alpha 1 a dash epsilon. Alpha 1, check it alpha 1 is nothing but a star f. Okay, so alpha 1 is nothing but a star f. Then a dash is nothing but a t dash epsilon. That's all. Okay, so then anyhow this third one is not in the area left recursion. Keep it same. Nothing, a very easy. If you know this, so you should write. If you first you should represent that production in the form of a alpha 1 beta 1. That's all. A alpha 1 beta 1. You should represent that. A tends to a alpha 1 beta 1. Okay, so first you should represent that one. After that, you should write the recursion. A tends to beta 1 a dash is equal to alpha 1 a epsilon. Alpha 1 a dash epsilon. That one you should write. See, once again, I will tell E tends to E plus T star or E. We should represent this one in the form of A tends to A alpha. Now here E is becoming A, then E, that is A. So then this plus T we will represent as an alpha 1, then T is the represent beta 1. So this one we will convert in the form of A tends to beta 1 A dash. So here E tends to beta 1 is nothing but T, A dash is nothing but E dash. So then here E dash tends to, that is A dash tends to alpha 1 A dash epsilon. Okay, so a dash is nothing but here e dash, and alpha 1 is nothing but a plus t. Alpha 1 is nothing but a plus t. I have written plus 1, then a dash and epsilon. Okay, so like that, this one also you should convert. T tends to t star f or f. So this one represent in the form of a tends to a alpha 1. So here t is a and this t is a. Then star f I am making as a alpha 1, that is a alpha 1. This f becomes beta 1. Okay, so here, so represent in the form of a tends to beta 1 a dash. So t tends to beta 1 is nothing but a f and t dash. A dash is nothing but a t dash. Then t dash will be, that is alpha 1 t dash epsilon. Alpha 1 is nothing but a star f and t dash then epsilon. That's all. So then f tends to e is not in the left recursion. So you should write same thing. Okay. So then the final grammar obtained after eliminating the left recursion can be written as shown below. E tends to t e dash. Okay. Same thing you can copy here. E dash is equal to plus t e dash epsilon. Okay. So then sorry, here t is once again written. Okay. Remove this t. That's all. Then t star t tends to f t dash. Okay, and t star same thing you can write star f and t dash and epsilon. So this remove this. Okay, then f tends to e id. Same thing. So same e tends to t e dash is equal to plus t e dash epsilon. T tends to f t dash and t dash tends to star f t dash epsilon. Okay, so like that. So they will give the one grammar in exam also. So remove the left recursion. So at that time you should represent in the form of a tends to a alpha 1 beta 1. Okay, so then after that, after representing that, you can convert that one into a tends to beta 1 a dash, then a dash is equal to alpha 1 a epsilon, a dash epsilon. Okay, like that we need to remove the left recursion. Like that, we will take one example, another example. Eliminate the left recursion from the following grammar. Okay, so eliminate the left recursion from the grammar. Okay, so here S tends to capital A or B. So here, then after that, A tends to AC or ST epsilon. See here in that, first check which one is not, which one is in left recursion. So S tends to capital A or B. So here we don't have any left recursion. Okay, so here variable a is there, s is there, variable a is there. Okay, so that is we don't have any left recursion. So here we have a tends to ac. So here a is there. So here we have a left recursion. Okay, so here first thing is what we need to do. So first step, the S production doesn't have left immediate recursion. Don't consider this production. S tends to a b. So don't consider this production. Step 2, consider the production. A tends to AC, SD, E. So here replacing the non-terminal S. So here non-terminal replaced by S, we will get a by S tends to AB. So replace this S with A or B. Okay. So here replace with, so here AC. So here for S, for this S, I am replacing A, capital A, D, and B. Okay. So on this BD epsilon. Okay, so here for S I have replaced with BD. Okay, so here both things I am replacing with S. So S is, so instead of this S I am putting AD, and instead of S I am putting B. Same thing I am doing. So here AC, same thing, and here SAD is there. So this S will be removed. SD is there. So this SD is there. Remove that SD with a capital A, small a, and here yes, remove this SD is there now. So remove this S and put B here. Okay. So here we'll have AC, AAD. So BD we have got this one. So now the grammar obtained after eliminating the indirect left recursion, we should have the final grammar. So here we don't have indirect left recursion. So here S tends to capital A, B. So here we don't have any left recursion, and A tends to AC. So here we will have a left recursion, and A tends to A. So here also we will have left recursion. Okay, so BD epsilon. So these things they have given. So we need to convert this one into left recursion. Same thing you should represent in the form of A alpha 1, A alpha 2, and you can then write the grammar using A tends to beta 1, A dash, A tends to alpha 1, A dash. Like that you should write. So here S tends to capital A, B. So it doesn't have a direct left recursion. It doesn't have left recursion. Keep it same thing. So now you should write this one AC, A capital AD, VD epsilon. So you should write this one in alpha A alpha 1, beta 1, A alpha 2, beta 2. Right, like that you should write in the form. Okay, so here A, same thing. So here C, you should write A alpha 1. A tends to A alpha 1. So here A tends to A alpha 1. C is nothing but an alpha 1. Then this is A. Then AD, this is alpha 2. So then after that we have VD, beta 1, here epsilon, beta 2. Okay. So now you should write in these two form. Okay. So here you should write this A tends to beta 1, A dash. Okay. So here A tends to beta 1. Beta 1 is nothing but BD. Beta 1, A dash. Okay. So then beta 2, A dash. So beta 2 is nothing but epsilon, A dash. I have written. Then A dash will be written as alpha 1 A dash epsilon. Okay. So alpha 1 is nothing but a C A dash. Then alpha 2 is nothing but AD. Alpha 2 is nothing but a AD dash A dash. You should write. Then after that epsilon. So like that we will write. Nothing is there. Very simple. If you represent this in this form, first you represent A alpha 1, A alpha 2 form, beta 1, beta 2 form. Then write that recursive production, write recursive production. A tends to beta 1 A dash, then A dash alpha 1 A dash epsilon. Okay. So here I will once again I will tell. Okay. So A tends to beta 1 A dash. So beta 1 is nothing but BD A dash. Then beta 2 A dash, that is epsilon is nothing but a beta 2. Okay. So that is epsilon A dash. Then A dash alpha 1 A dash epsilon. Alpha 1 is nothing but C A dash. Then alpha 2 is nothing but AD A dash epsilon. If you write this one, you have remove the left recursion. So whole thing will be written as so consider this one is also added. Then S dash S tends to AB. So then A tends to BD A dash or A dash. Okay, so epsilon A dash now. So we can read that. So we have got this one. S tends to AB, capital A B, and A tends to BD A dash, epsilon A dash. Then A dash tends to C A dash. This one same thing we have written. It can be rewrite also. So S can be same thing you can write here. So this one you can give BD A dash and A dash. So remove that epsilon. Then A dash is the C tends to AD. Then AD tends to A dash and epsilon. So this remove this epsilon. No. If you remove that one also, there is no difference at all. Okay. So like that we will remove the left recursion. Okay, so this is an algorithm. Okay, so here same thing, whatever the steps we have done, same thing we have written here. So here, what is the input? So that is grammar G with E productions with no cycles. Okay, so that one we need a grammar G without E productions with no cycles. The output will be grammar without left recursion. Okay, the grammar without left recursion, it may have E productions arranged non-terminal in the order A1, A2, A3 to En. Okay, so here for I1 to n, for j1 to I minus 1, do you need. So let aj tends to beta 1, beta 2, beta 3, beta. So you need to identify beta 1, beta 2, beta 3. Okay, let aj and replace ai with aj alpha. Same thing what we have done now. Same thing, replace that ai with aj alpha by ai tends to beta 1 alpha, beta 2 alpha, beta 3 alpha. Same thing whatever we have done now. So you should replace ai tends to aj alpha by. Okay, so the in this form we represent. Then after that we need to replace that one by ai beta 1 alpha, beta 2 alpha, beta 3 alpha. Okay, so like that replace for all the production, end for and eliminate the left recursion among a productions. Nothing is there, just whatever we have done the steps in the two examples, same thing we have written. Okay, so today we have discussed, what do you mean by left recursion and what are the different types of left recursions, then how we will remove the left recursion, then what is the algorithm of left recursions. Those things we have discussed in two classes.